Hi, welcome back. In the last session, we talked about structuring prompts with ICIO method and how few-shot prompting helps the model learn from examples. Today, we are taking the next step, making AI reason, not just respond. We'll explore chain of thought prompting, zero-shot COT, self-consistency. These are the foundations of getting accurate logical answers out of large language models. What is chain of thought prompting? Chain of thought prompting tells the model how to reason and show its reasoning instead of jumping straight to the answer. You can think of it as asking the model to think out loud. So this is critical for tasks that need multiple steps like math, logical reasoning, planning or troubleshooting. Let's do one thing, let's open ChatGPT and try it. Give it a prompt like solve this problem step by step. A farmer has 10 sheep. Three wander away and he buys five more. How many sheep does he have now? Now watch the output. Notice how the model breaks the calculation into steps and then produces the final result. This not only improves accuracy but also makes the reasoning transparent. You can see where the logic could go wrong. Pause the video, try this yourself in ChatGPT. You'll see how much clearer the reasoning becomes. So why COT works? When when we ask the model to reason step by step, we activate its in context reasoning mode. Without COT, the model often guesses based on statistical shortcuts. With COT, we explicitly request intermediate thinking, giving us verifiable logic and fewer hallucination. Next is zero shot COT prompting. Sometimes we don't have examples to include. That's where zero shot COT comes in. We simply instruct the model to reason step by step on its own. Let's give it a prompt and see how it breaks down. See how it breaks down without us giving examples. Even without examples, the phrase let's solve this step by step triggers the model to produce logical intermediate reasoning before it reaches the answer. This technique is simple but powerful. It works for math, cause and effect analysis, and decision trees. So, pause here, try this prompt yourself. You'll notice how this AI slows down and explains the logic. Let's try another example. Notice how the output is structured. It lists contributing factor in order, production cost, battery efficiency, policy incentives, all connected logically. Next is self consistency prompting. Now let's build on COT with self consistency. So instead of relying on one reason path, we ask the model to generate several reasoning chains and then select the most consistent result. In practice, this reduces random errors and improves reliability. So here I'm giving one more prompt. There are 15 trees in park. Workers plant more trees, and afterwards there are 21 trees. How many trees were planted? Solve this problem three different ways and give the most consistent final answer. You'll see multiple raising traces. The model may calculate 6 each time. If all raising paths converge on the same answer, that result is more trustworthy. This technique is essential for analytical or numeric tasks. So pause this and try this prompt. When you see the model converge on the same answer from different reasoning paths, that's self-consistency at work. So we use this method in practical uses like data analysis, business planning, coding. In every case, COT and self-consistency converts fast guesses into structured reasoning. So pause and think which of your own tasks could benefit from COT. Try plugging one into ChatGPT after this episode. That's a wrap for today. So far, we have moved from simple prompts to reasoning prompts, giving the AI a way to explain its thinking. You know how to make AI reason and cross check its own logic. In episode 3, we'll connect these reasoning methods into full workflows through prompt chaining, React, model optimization, which combines reasoning with real action. If you found this useful, save the template, prompt from today's example, and practice refining them with your own task.